In this absolute value problem, we have a distance, but it's no longer from 0. It's now the distance from 1 must be less than 3. So the distance of the variable x from the number 1 must be less than 3. So here's how the solutions look. Now the solutions can go up to but not including 4, down to but not including -2. Each of these and all of the numbers that are highlighted between 4 and -2 are solutions to this inequality. Now, when you drop the inequality, it breaks it up into two other inequalities. So if I drop the absolute value sign, this will become x minus 1 is less than 3 and x minus 1 is greater than -3. So when I switch, when I drop the absolute values, I keep the original and I switch the inequality and change the side on the right-hand side. Then I solve both. I add 1 to this side and get x is less than 4. I add 1 to both sides here and get x is greater than -2. So that's how I find these 2 points here. So in this problem, we're no longer concerned about the distance from 0. We're looking at the distance from 1. In this problem, we're concerned about the distance of x from the number 2. So in other words, the distance of x from 2 must be greater than 4. So it has to have a distance larger than 4 from the number 2. So if we look at the solutions, here's the number 2, and the distance that's greater than 4 from 2 starts at but not including 6, and all of these are solutions to that inequality. Starting at -2 but not including -2, all of these have a distance that's greater than 4 from the value of 2. Now to solve this by hand, when we drop the absolute values, we get two sets of inequalities. The first one looks exactly like the original, but it doesn't have the absolute values. The second one, I drop the absolute values, switch the direction of the inequality, and make the right hand an opposite sign, which is -4. Then I solve both. Add 2 to both sides, and I get x is greater than 6. Add 2 to both sides, and I get x is less than -2. So the solutions are x is greater than 6 or x is less than -2.